Okay, and here we have it that if one of the roots of the equation x squared plus px minus q equal to 0 is twice the other question we're having is the square of the other. So here just twice the other and their sum is 15. Find p and q. So again, I will start by saying let. I'm just letting, okay, like setting something. Let alpha and beta be the roots of that equation. Okay, so this means that if I add them together, I'm going to have 15, right? Remember, if one of the roots of this equation is twice the other and their sum is 15, so if I add the two roots together, I'm going to have 15 as a sum. But before then, you see that one of the roots is twice the other, alright? So from that statement, it follows that alpha is twice beta, or beta is twice of alpha, given that one is 2 times the other. So as always, I would like to work with alpha, so I'm going to make use of this one, alright? Yeah, I will work with alpha. You know, God is the alpha and omega. It's not alpha and beta, so there's no beta there. Just alpha and omega. I wish we have omega. Okay, so we have beta equals to 2 times alpha. You can decide to work with this, alright? It's still going to be the same thing. It's still going to make sense. So from there, it means that the sum, alpha plus beta, is going to be alpha plus 2 alpha, which you know is 3 alpha. The sum is said to be what? 15. And again, the sum is always negative b over a. So, say this is 15, alright? Which is the same thing as negative b. B there is p over a. A there is just 1, alright? I hope you are getting it. The sum of the two roots, since I'm saying let alpha and beta be the roots of the equation, it means that alpha is 2 times beta or beta is 2 times alpha, and I decide to work with this one without any loss of generality. And I'm saying that the sum of the two roots, alpha plus beta, which is, in place of beta, I'll just put 2 alpha. So, alpha plus 2 alpha, which is just 3 alpha. Since it was given from the question that the sum will be 15, so I'm just putting it down 15, alright? And we know that the sum of the roots will be giving us negative b over a, where b here is p, and a here is just 1, so negative p over 1. I'm going to do the same thing for the product. So you see the chains of equality signs. So I'm going to do the same thing for the product. I'm going to say that alpha times beta, alright, is, well, we are not given the value for the product from the question, so we just have to work it out. So alpha times beta is, we know it to be negative, we know it to be c over a, where c is just negative q, alright, and a is just 1. But it is the same thing as beta here is 2 alpha. So alpha times 2 alpha, which you know is 2 alpha squared when you multiply this, alright. So from the fact, we know it to be c, which is negative q, over a, which is just 1, alright? In fact, let me make it longer. This is negative p, and this is just negative q, like that. Okay. So, our concern here is to know what p is and what q is as well. Well, I can make this a little bit simple so that we can get the values of P and Q from these two equations. So I can decide to call this equation 1 and 2, okay? So from here, I'm just going to take some things out of it. I'm going to take some things, not everything. So let me put it down with the blue ink. So from that blue ink right here, right, from the blue ink, we have it that 3 alpha, which is this point, is equal to 15, which means that alpha is 5, right? So since we have that 3 alpha is 15, it means that alpha is equal to 5, okay? Again, we know that 3 alpha is equal to 15, which means that 15, okay, is negative p. So from there we can just get the value of p. Very short. Since 15 is equals to negative p, it implies that p is equal to negative 15 by just multiplying negative 1 on both sides. Multiply both sides by negative 1, just get that p equals to negative 15. So you can keep that and try to find the value of q, given that alpha is equal to positive 5, right? Okay, so that is it. So from this second equation, we see that 2 alpha squared is equal to negative q, and alpha is given to be 5. That means that 2 times 5 squared, alright, is the negative q, which means that 5 squared is just 25, and 2 times 25 is 50, which means that 50 is negative q, which implies that q is negative 50, alright? So the value of p is negative 15, and the value of q is negative 50. Okay, so that's a nice place to stop, and that's what you get. Let me see if I have a few more questions on that. Okay, I have a few more and very, very toxic ones. Alright, let's move over to that. Now here we are to find the equation with roots alpha and beta, given that alpha minus beta is equal to 3 and alpha squared minus beta squared is 6. So given the two equations, okay, we are to form an equation where alpha and beta are the roots. So from what we've learned already, if alpha and beta are the roots of an equation, then if we sum the two roots together, let's say this is the equation, x squared minus something x plus something equal to 0, right? So if alpha and beta are the roots, then the sum will be here and the product will just be here, alright? So we just put it down, alpha times beta, and then alpha plus beta like that, and that will make a lot of sense. And that makes a lot of sense. So our work is to go ahead and find the sum of the two roots, alpha and beta, and also find the product of the same two roots, alpha and beta. And when we get those things, we just plug them in right here, and that would give us what we want, right? The equation with these roots. So given these two equations, the first one is alpha minus beta equals to 3, and alpha squared minus beta squared equal to 6. These are the things we'll be making use of, right, to get the new equation. Okay, so I would like to go ahead and call this 1, and maybe just call this 2, right? Now from 2, I see that alpha squared minus beta squared is 6, alright? So from the second equation, we can see that alpha squared minus beta squared is 6. Excuse me, 1 minute. So since alpha squared minus beta squared is 6, then, on the left hand side, we're just having difference of two squares, alright? And by difference of two squares, this is a square and this is a square, and we just have the difference of those two terms like that. I can factor this. I'm going to have alpha minus beta times alpha plus beta, or beta plus alpha, the same thing. Alright? And I'll equate that to 6. So we can factor this into this form, such that we multiply these two brackets. If you just multiply everything there, you get this back. Okay, so by having that, remember that I said we just need to get their sum and just need to get their product. Maybe possibly we can get the two values, the value for alpha and the value for beta, then we just add them together and we multiply them together, and we have the sum here, the product here. Anyway, but since from factoring this, we have alpha minus beta times alpha plus beta, I see that alpha plus beta is here, which is what we want, alright? So we can simply make that a subject of formula. Okay, so from there I can simply say that alpha plus beta will give us 6 divided by alpha minus beta like that, by just dividing both sides by alpha minus beta, and we get this. So on the left hand side, we just have alpha plus beta. Now, from equation 1, we see that alpha minus beta is equal to 3. So we're just going to substitute 3. In place of alpha minus beta, we're going to have 6 divided by 3, which is just 2. So this means that alpha plus beta is equal to 2. Okay. And that's very nice, alright? Now, since we've gotten the sum, I would like to do this. I'll just put it down here. X squared minus the sum, which is just 2. And I put down the x plus the product. So we will need to get the product, alright? Now, there's no way I can just simply get the product from this. I have to solve for the values of alpha and beta, or the manipulations will be too much. So let me just do it straight. So I will have to solve for the values of alpha and beta, and I will need 2 equations for that, okay? So I would like to use this equation, that alpha plus beta is equal to 2. It's an equation, provided it's an equality sign. And I would like to make use of my equation 1, where alpha minus beta will give us 3. So let me say I call this equation 3, and I bring back equation 1 equals to 3 bar. Okay, so this was our 1. Let me just still keep it like that. So by summing these two guys together, I would like to add these two things like this. By adding them together, we see that alpha plus alpha is alpha squared. 2 alpha. Then beta minus beta is going to be 0. 2 plus 3, that will be 5, alright? So here we equate it to 5. So that means that 2 alpha is equal to 5. So by getting that, we can simply say that alpha equals to 5 divided by 2. Okay, so that's very nice. Now that we've gotten that alpha is 5 over 2, to get a product, we need to multiply with beta. So what's the beta? Well, we can simply substitute into any of these equations and get the value of beta, right? Let's say we substitute into equation 1. We're going to have alpha, in place of alpha in this equation 1, we're going to have 5 over 2 minus beta is equal to 3, which implies that we've multiplied by -1 and turn things together. Beta is 5 over 2 minus 3, alright? Just trying to solve for the value of beta, that's what you get. Okay, so beta will now become, the 5 over 2 is something as 2.5. So 2.5 minus 3, right? You're subtracting 3 things from 2.5 things. You'll be owing half, 1 over 2, that is. You'll be owing 1/2, right? So that is just -1 over 2. So alpha is 5 over 2 and beta is -1 over 2. So their product, alpha times beta, will be 5 over 2 times -1 over 2. And you can just see, this will give us -5 over 4. Like that, alright? And in fact, I would like to take out some things. This is now the negative. And this is just -2 here. Okay, so this is an equation, but since I'm having a fraction here, I would just like to get integral coefficient, that is integers as coefficients for each of the terms, alright? Coefficient of x, actually. This is x to the power 0. So I would like to get integral coefficients. Because of that, I would like to multiply through by 4, so that here the denominator here will just be 1, just like every other term. So by multiplying through by 4, I will have 4x squared minus 8x minus 5 equals to 0, because 0 times 4 is just 0. Okay, so this is the equation that I will be required to find given the two conditions for alpha and beta. Okay, well, that's very nice. Let's move on to the number 7 question. Now here we are to find the equation whose roots are the cubes of the roots of this equation. Find the equation whose roots are the cubes of the roots of this equation. Well, let alpha and beta be the roots of the given equation, right? This is equation. Okay, so if alpha and beta are the roots of the given equation, then you have to find the equation whose roots are the cubes, okay, of the roots of the equation. So by cubes, that means we have to find the equation whose roots are alpha cube, whose roots are the cubes, okay, and beta cubed, like that. So by saying that whose roots are the cubes of the roots of the equation, so when you have the roots of this equation, then the cubes, right, each of them will be the roots of the new equation we are asked to find. Okay, we've tackled problems like this before. We will have that we have to find the equation whose roots are alpha times beta plus beta, and alpha times beta plus alpha. There's some questions back, few questions backward. So we will just go ahead and establish the fact from the given equation. We know that A is 1. We know that B is negative P, that is the coefficient of X, and then C is just Q, like that, right? Okay, so we will need to sum the roots, the given roots. So you let alpha and beta be the roots of the equation. So that means that alpha plus beta will give us negative B over A. So negative B here is negative P. So negative of negative P, that will be positive P over A. A is just 1, alright? So that will just become positive P over 1, which is positive P. And their product, alpha times beta, is, well, C over A. So C is just Q. Q over A is 1. So it's Q over 1, which is just Q, like that. So we see that the sum is P and the product is just Q. Okay. Now we have to find the equation whose roots are alpha cubed and beta cubed. Then it means that the required equation will be of the form x squared minus alpha cubed plus beta cubed x plus alpha beta cubed equal to 0, right? No, when we have that is just equal to 0. You know, when we have the roots of our equation, when we sum them together, it gives us the coefficient of x, and when we multiply them, it gives us just the constant. So this is pretty simple, okay? It has the same format. So the required equation will be of that form, alright? So all we need to get is the sum of the two roots and the product of the two roots. You know that alpha cubed times beta cubed is the same thing as alpha times beta all cubed, because they're having a common power, right? And they are being multiplied together. If they were added, you don't have to try that. It's risky, it's deadly as well. Okay, so let me just use this part to sum them together. And alright, so the sum of the two roots, alpha cubed plus beta cubed. Well, we want to represent that in a way that we can always get alpha plus beta and alpha times beta from it. So I'm going to try to rewrite that in different ways, alright? Kind of factoring it, alright? And, okay, well, this is going to require a lot of work, and I will not have to go through that. All I want you to know is that when we have alpha cubed plus beta cubed, it is the same thing as alpha plus beta times alpha squared minus alpha beta plus beta squared. So when we have alpha cubed plus beta cubed, you can factor this into alpha plus beta times alpha squared minus alpha times beta plus beta squared. If I get this minus alpha beta, this and that. Okay, now this can be gotten from the binomial expansion of alpha plus beta all cubed. This will just give you alpha cubed plus 3 alpha square beta plus 3 alpha beta square plus beta cubed. If you want to expand this, alright, using binomial expansion, or you want to go the long way, multiply this 3 times and multiply them 3 times and try to simplify things. This is what you will get. So by making alpha cubed plus beta cubed subject of formula, alright, you will have to get, let me just put down all the works for you, Sha. Alpha cubed plus beta cubed, this will give us alpha plus beta all cubed. You know, you have to subtract these 2 things from both sides. So that will be minus 3 alpha square beta plus 3 alpha beta square. So I'm putting that in a bracket. So this minus has affected all the terms here. Okay, so I'm going to go ahead and factor out some things. So I'm going to factor 3 alpha beta. We're going to enter with alpha plus beta in there. And here we just have alpha plus beta all cubed is alpha squared plus beta cubed. Sorry, alpha cubed. So you see from here now, we can also make use of this, alright? Or maybe you want to go further and reach this form so that you see that this is equals to that. Maybe let me just show you that and I will go back and use any one I want to make use of. So from here you see that this is cubed and this is just a single power and I can factor that, alright? So we can just factor alpha plus beta, okay? And the big bracket we're going to have alpha plus beta all square. Well, this is not really necessary. Minus 3 alpha beta. We can just go ahead and expand this again. Alpha plus beta all square is the same thing as alpha square plus 2 alpha beta plus beta square minus 3 alpha beta. So you see, 2 alpha beta minus 3 alpha beta is negative alpha beta. This is just alpha square, just put it down, plus beta square. And that is it. This is alpha plus beta. So you see from here, it is the same thing as that, alright? So you can actually get that. It's the same thing, okay? But in the process, I just discovered that from here, I was going to simplify some things, which will lead me to this point, alright? So instead of making use of what I want to make use of before, I can just simply put this down, knowing that when I expand this, I will get this one. So I'll try to make alpha cubed plus beta cubed subject of formula, and you will just have something like this. Though you can simplify from here, but this is a nice place to stop and make use of it. So I'll just have to use that, alright? Okay, so let's see. From here we can enter with, let me erase from here. So we know that alpha plus beta is P. So that is what I mean. We just put it down, P, and we cube it. We just cube that. Minus 3 times alpha times beta is Q. And again, alpha plus beta is P. So this is alpha cubed plus beta cubed. So we are saying that their sum is alpha beta cubed minus, sorry, not beta, is P, right? Yeah, it's P. What is wrong with beta? That is P. So alpha cubed plus beta cubed is P cubed minus 3QP or PQ anyhow. That's just for the sum. The product is not going to take that much work. So the product will just be alpha cubed times beta cubed, which is alpha beta all cubed. Alright? And that is alpha times beta is just Q. So you just cube that. Alright? Okay, so knowing that this is a general form of the equation, their sum and their product, maybe I just use this part of the board to put that down real quick. So we're going to enter with x squared minus the sum p cubed minus 3pq, which is something as 3qp, alright? p cubed minus 3pq. Alphabetically, we have the x, and again, we add it with their product. So their product there is just q to the power 3, and we equate that to 0. So this right here is the equation we're required to solve for, whose roots are the cubes of the root of the given equation. Okay, so that is very nice, and that is what you get. Well, let's move over to the next question be the last question under the roots of a quadratic equation. Well, this question is a kind of a very different one from the others we've been doing, alright? But it's very simple as well. Yeah, we can actually deal with it. Now, it goes that if alpha squared plus 1 and beta squared plus 1 are the roots of this equation, then find the equation whose roots are alpha and beta. So this is like a reverse direction. What we've been doing the other times will be that if alpha and beta are the roots of a certain equation, then find the equation whose roots are, then they now give us an expression for the two new roots, or for the two roots of the new equation, or for the roots of the equation we are to find. But in this other case, we are already given an expression in terms of alpha and beta. This in terms of alpha, this one is in terms of beta, as the roots, alright, of this equation. Then we have to find an equation whose roots are just alpha singly and beta just like that, a reverse direction. This is also simple. So we'll continue to use what we use, alright? We know that A is equal to 3, B is -4, and C is just +1, alright? Okay. Well, since alpha squared plus 1 and beta squared plus 1 are the roots of the equation, it means that the sum of the roots will give us -b over a, alright? It implies that the sum of the roots, that is alpha squared plus 1 plus beta squared plus 1 will give us -b, right? Let me just put this down. -b over a. So that is negative of b is just -4. A is just 3, right? So that will become negative of -4 over 3. That's just 4 over 3. So I would like to clean things up. I'll just put it down. 4 over 3, alright? And again, their product, that is alpha squared plus 1 times beta squared plus 1, will just give us positive c over a, where c is just 1 and a is 3, that is just 1 over 3, like that, right? Okay, so that is very nice. We have that their sum will be 4 over 3 and the product will just be 1 over 3. Well, let me go ahead and give these guys some names. Let me call this 1 as usual, and I circle it, and this is 2. Okay, now this is what I would like to do. I will see that from 1, let's simplify the expression on the left-hand side a little bit. So we're going to have, from 1, we're going to have alpha squared plus beta squared plus 2 is equal to 4 over 3, right? No, alpha squared plus beta squared, 1 plus 1 is going to be 2. Maybe just keep this alpha squared plus beta squared here. That will be 4 over 3 minus 2, right? Subtracting 2 from both sides. Okay, so you know 4 over 3 is the same thing as 1.33333333. The 3 keeps on repeating without an end. So if you subtract 2 from that, you're going to get negative 0.67. That means alpha plus beta square is going to become negative 2 over 3. Alright? Just take that out. You're going to see that. Alright. So from here, well, let me pause here and say something. You know, we are to find an equation whose roots are alpha and beta. Alright? In other words, we are to find an equation, and the equation will be of this form. So let me just put it down. To find x squared minus x plus equal to 0. So if you have an equation whose roots are alpha and beta, it means that alpha plus beta will give us the coefficient of x, alright? And the negative of that. Then alpha times beta will just give us the constant term. So we have to find the sum of the two roots and the product of the two roots, so that we just put it into this form, and that will be the equation, okay? So our aim here will be to get something alpha plus beta and to get something for alpha times beta, right? Okay, so let me just put this down. Okay, so we continue that alpha plus beta square, alpha square plus beta square is equals to negative 2 over 3. Now if you can, I don't know if you can see that this is a little bit awkward. You know, alpha square, you know, you just squared something, the result is going to be non-negative. It's either going to be 0 or greater than 0. For all the numbers for all the real numbers, if you say negative 1, square of negative 1 will be positive 1. Square of negative 10, okay, will be positive 100. So, whatever number you have, if you square that number, the result will be greater than 0 or equal to 0. If that number is 0, that's the case. And the same thing for b. So, if you're adding two numbers, which is non-negative, how then do we have a negative result? So, this is a little bit awkward, but by the way, we will just play around with it, and we are going to observe what it will give us anyway. So from here, I would like to go ahead and rewrite this as alpha plus beta all squared minus 2 alpha beta, and I call that negative 2 over 3. Now, again, you know, if you expand this, you're going to have alpha squared plus beta squared plus 2 alpha beta minus 2 alpha beta will leave us with alpha squared plus beta squared. So that is just it. Okay, so from here we can see this is the sum and this is just the product, alright? Maybe I just call this something. Maybe I just keep it somewhere. I just call it star, like this, using the red ink. Okay, I will also refer to the second equation from equation 2, alright? So from 2, what do we get? Well, we see that to expand this on the left hand side, we're going to have alpha times beta all square plus alpha square plus beta square plus 1 is equals to 1 over 3. Like that, alright? Okay. Well, now, very nice. Maybe I didn't even need to do something here. Very nice. We see that alpha square plus beta square is here, right? This is it. And it was equal to negative 2 over 3. So in place of alpha square plus beta square, I will just put negative 2 over 3 there, right? Okay, so I'll just have to put this up. We're going to have alpha times beta all square. Then in place of alpha square plus beta square, it is negative 2 over 3. So I'll just put it down, negative 2 over 3. And now add it with 1. Plus 1 should give us 1 over 3. So here I can get my value for alpha times beta. Very simple. Then that means that we're going to have negative 2 over 3 plus 1 is going to give us positive 1 over 3. Okay, so that means that alpha times beta all square plus 1 over 3 is equal to 1 over 3. Now look at this. You are adding 1 over 3 to something. It still gives you 1 over 3 as a result. Then that thing must be 0. Alright? So this is alpha times beta all square is equal to 0, which implies that alpha times beta is 0. So that is for the product. So maybe here I would just like to put 0 for it. Let me just indicate that this is equal to 0. So we just need to get their sum, right? This question is very, very interesting anyway. For the sum of the two roots, well, we can get that from this star, right? This one that I starred over here. We can get that from star. Let me just put it down from star. And I circled it. We see that alpha plus beta, all of them square. Now, since alpha times beta is equal to 0, Alright? So alpha times beta will be 0, and 0 times negative 2 will just be 0. So that means alpha square plus beta square, alpha plus beta all square will be equal to negative 2 over 3, because this term is just equal to 0, alright? The whole of that is just equal to 0. That means that alpha plus beta will be equal to square root of 2 over 3, negative of that. So to get alpha plus beta, we just need to take the square of both sides. So square of both sides, we have negative 2 over 3, the square of that. Here is the awkward stuff. You're having a square root of a negative number. The result is not going to be a real number anyway. But we are not concerned with that, alright? So we just have to take the square root of negative 2 over 3 in place of this. So it's going to be square root of negative 2 over 3. Maybe I just have to rewrite that. I don't like it that way. Maybe I'll just have to split that into 2 by putting it this way. Square root of negative 2 on top divided by square root of 3 at the bottom, alright? So, okay, so that makes sense. And this is a fraction which I would like to get rid of it a little bit. Oh my God. Let me just put it down anyway. Negative 2 divided by square root of 3. Okay, I'll clean a little part of this board and I will give us the equation we were to find. Now we are going to have x squared minus alpha plus beta is now square root of negative 2 over square root of 3x plus alpha times beta is 0, so there is no point if this is just equal to 0. Well, since this is a fraction, I'll just like to multiply square root of 3 throughout in the equation. We're going to have square root of 3x squared minus square root of negative 2x. Alright? The x is not under the square root sign. This is equal to 0. And this right here is the required equation. And that makes a lot of sense, alright? Okay, so this is the last question under root of the quadratic equation. So I just selected questions that concerns root of the quadratic equation. And these questions are very, very interesting. You've seen that. Okay, I'll be solving questions under logarithms and trigonometry and other topics, other interesting topics as well, and challenging questions as well. Okay, thanks for watching, and please subscribe to this channel.